Dear students, welcome back. This is Dr. Biju Vasdevan. In this video, we will discuss the topic 9.9 Independence of the path. And I think I have given a hint on the last chapter about independence of the path, isn't it? So now we will discuss it deeply. We will see in this section line integrals that involve certain kind of vector field f that depend not on the path C but on the endpoints A and B. For example, you are integrating along the curve from A to B, isn't it? This is a curve C1. So when you integrate from A to B, assume that there are many curves moving. There are possibly many curves, isn't it? When you integrate along C1, C2, C3, C4, C5, you get the same answer. So it means that it doesn't matter which curve you are traveling through. It is depending on the end points, where you are starting and where you are ending. So the integration is depending on the end points, not the track, right? So in such cases, we call it is path independent, isn't it? So the f is depending on the path or not. That's what the f vector is depending on the path or not. That's what we are going to analyze here. There is a definition for it. Conservative vector fields. Before proceeding, we need to introduce a special kind of vector field called conservative vector field. What is conservative vector field? Slightly explain here. A vector function f either in 2 space or 3 space. If it is in 2 space, there will be Pi Qj, isn't it? If it is 3 space, f will be Pi Qj Rk. And remember, if it is 2 space, p will be function of xy, q will also be function of xy. In 3 space, all the 3 terms p, q will be functions of x, y, and z. It's okay. A vector function f is said to be conservative if it can be written as a gradient of a scalar function pi. What do you mean by gradient? Gradient, if you have a function, scalar function phi, which is function of 3 variable, assume that we discuss it for 3 variable and then you can adjust for 2 variable. If it is a scalar function, phi is a scalar function of 3 variable, gradient, del operator, we know del gives 3 different operations, gradient, divergence, curl, isn't it? Del phi is called a gradient of phi. Del phi is nothing but the direction of maximum change of phi. So this vector can be said a conservative vector field if it is a direction of maximum change of a scalar function. So in this direction, if it is direction of maximum, it has no rotation. So the divergence, that is the curl del cross f, will be 0. Another way you can verify the cross product of the vectors will be 0, del and f, isn't it? In other words, f is conservative, there exists a function phi. So if f is conservative, then there exists a function, scalar function phi, such that f can be expressed as gradient of the scalar function. So whenever we find f vector is conservative, then immediately we get another conclusion that f is nothing but del cross pi, del pi, it's not cross, del pi, gradient pi. So there is a pi whose gradient is nothing but f. So this is the conclusion we get. There are many results. Path independence. If the value of a line integral is the same for every path in a region connecting the initial A and B, initial and terminal point B, initial point A and terminal point B, then the integral is said to be independent of the path. That's what we have seen in the previous introduction part, isn't it? In other words, a line integral f dot dr along C is independent of the path if integral over C1 is equal to integral over C2. Any curve for any two paths C1 and C2 between AB. Okay. Fundamental theorem. What is the fundamental theorem? Suppose C is the path in an open region R on the xy plane, two-dimensional space we are considering. C is a path in a two-dimensional space defined by R of t. R of t is x, a positional vector. R of is x of t I, y of t j, and t is given between A and B. F, the vector field, is given as pi plus qj for two-dimensional space. F vector is conservative vector field in this region R, and pi is potential function for f. Then we know f is conservative, then f can be written as del pi, isn't it? So they replace f by del pi. And then further, this integration can be evaluated without integration. If you know what is pi, this is substitute upper limit for pi. C is from A to B. We are integrating from A to B, capital A to capital A and to B, the end points, isn't it? So pi upper limit will be substituted, and then minus pi at lower limit, isn't it? Capital A is the substitution of this value in the lower point, and capital B is substitution of B in the point x of B, y of B. Is it clear? Okay, just note down, that is, if you find f is conservative, then f dot dr can from capital A to B can be evaluated by pi of B minus pi of A, where we need to find pi. Pi is this is the scalar function of the function f vector, isn't it? So if f vector is conservative, there is a pi, otherwise no. So if f vector is conservative, then we will find a pi and then use the phi to find the solution without integrating it, possible, right? That's the conclusion of this theorem, fundamental theorem. Some equivalent concepts. If an open connected region R, in an open connected region R, integral f dot dr is independent of the path C if and only if the vector field is conservative. So they are interrelated, all the results, isn't it? If vector is conservative, then the integration is path independent. If and only if both the parts are true. If the integration is path independent, then the vector is conservative. If the vector is conservative, then the integration is path independent. So that is if and only if. Second equivalent concept. In an open connected region R, the integration is path independent if and only if integral dot f dot dr is 0. Because if it is independent, then it is conservative. Then conservative del cross del pi is 0 for closed path, because this is for closed path, because A and B will be same, upper and lower limit will be same, therefore integration will be 0. Integration from a point to the same point will be always 0, whatever the function is said, isn't it? So that is the, because it is closed path. And test for a conservative field. We know conservative vector field means it's a del cross f should be 0. What is the formula for del cross f? And we are considering a two-dimensional field, isn't it? P and Q. So del cross, the cross product of del and f is I j k or j k. Component of del, dou by dou x, dou by dou y, dou by dou z. Component of f, what is it? First component is p of xy. Second component is q of x comma y. Third component, there is no third component here, it is 0, because it is two-dimensional case, isn't it? Then what do you get when you find the determinant? I times 0 minus 0, this is 0, minus j times 0 minus dou p by dou z plus k times times k vector times what is it, dou q by dou x minus dou q minus dou q over dou z, this 2 and this one, isn't it? Dou q over z minus dou p over dou y. And you remember p is a function of only x and y, so dou with the derivative, partial derivation with respect to z will be 0, so these first two terms will be 0. Only last term has some terms. This will be k vector times dou q over dou x minus dou p over dou y is available, isn't it? If del cross f is 0, this term is also 0. We know del cross f is 0. So the answer is 0. So this implies that dou q over dou x should be equal to dou p over dou y. Shortly we can write qx is equal to py. When f vector is given as pi plus qj, take the component q here, differentiate it with respect to x partially, that is qx. First part p with respect to y, that is py. If they are equal, we can say f vector is conservative. That is what given here, dou p by dou y is equal to dou q by dou x. Otherwise qx is equal to py or py is equal to qx, isn't it? This is what the meaning of theorem 9.9.4. Now exercise starts. Question number 1, isn't it? What is it? Show that the given integral is independent of the path. Okay, we have, if it is two-dimensional case, easily you can check qx should be equal to py. Here this is q, this is p. Let's try first. What is q to xy? Then what is qx? Differentiate with respect to x partially to y. And what is p x to y? No, with respect to, okay. This is p, this is q, this is p q. So q is, this is p, py py, we want py and is equal to qx, isn't it? First term is p, second term is q. So p is 2xy, py is 2x. Q is equal to x square, qx is equal to 2x. They are equal. Py is equal to qx. So question number 1, show that the given integral is independent of path, isn't it? If it is conservative, obviously independent of path. Therefore f vector is conservative, then the integral is independent of the path. First answer is done. Next, find phi. If it is conservative, immediately f can be written as del phi. We have to find phi. Next, use a convenient path between the end points to evaluate the any path you can take. Any convenient path between the end points, right? That is third one. Find potential function phi, then use theorem 9.91. So we are going to find phi. Let's do it on a separate sheet. Okay. What is given us? And the question given us integral 1, 1 to 2, 4 to xy dx plus x square dy. And you should remember this is nothing but f dot dr. This is f dot dr. For example, if f vector is 2xy I plus x square j and dr vector is dxi dyj, find the dot product of f dot dr. You will find this one, isn't it? first dxy into 2xy into dx first term, x square into dy second term. So this is nothing but given is integral over cf dot dr. Okay, that's what we are finding. So f is given, first term is p and q we have used, that's okay. Since f vector is conservative, there exists a scalar function, we call it scalar potential, scalar function phi we can call it phi, p h I, phi, such that phi, okay, such that f vector is nothing but gradient of the scalar. And now remember what is gradient of a function. F vector is 2x yi vector plus x square j vector, which is equal to gradient, which is ixi plus phi yj. You remember gradient is, you can say dou pi by dou xi, dou pi by dou yj. You can write one more time, it is 3-dimensional space. This is 2-dimensional case, so this is phi x, phi y, phi xi, phi yj. This is what you get. From this equation, let this be equation number 1. From this equation, what do you get? Phi x is equal to 2xy, phi y is equal to x square. So we use these two information. So let's write again in the second page. Phi x is equal to 2xy, phi y is equal to x square. So this is differentiation with respect to x. Partial derivation with respect to x is 2xy. So when you integrate this function both the sides with respect to so what is phi? When you integrate both the sides with respect to x, this is integral to x square, so integral to xy dx. So y should be treated as a constant now. What do you get here? It is 2x square over 2 times y, and there should be a constant. The constant can be a function of y because this is pi. When you differentiate pi, you should get pi x. When you differentiate this, I am writing another final version of pi. Pi is x square y plus there is a function of y, because when you do partial derivation with respect to x, this term can be 0 and you can get, so partial derivation deals other variable as constants. So the removed term by differentiation can be a constant or a function of y. So this is the phi. But we don't have an idea about h of y. We need to find h of y, isn't it? And now from this one find phi x. Differentiate again with respect to y, because from phi x we have found pi, isn't it? From phi we are finding derivation. Differentiate both sides with respect to y. This will be x square, this will be h prime of y. Differentiate with respect to y, isn't it? Differentiate with respect to y. So h y of y, you can say derivation with respect to y. Okay, now compare. This is equation number 2 and this is 3 and this is 4 and this is 5. Compare 5 and 3. What do you get? 3 and 5 will give you, both are same, isn't it? Only one term is missing, this one, h. So h of y is not a function of x, only y, isn't it? Only y involves there. Therefore h prime with respect to y is of y is equal to 0. Therefore h of y should have been a constant c. Should have been a constant c. H of y should have been a constant c. We will check one more time whether h of c is okay. h of y is a constant c. Therefore, our final equation is phi. We need to know what is h of phi. If there is a constant, it can be differentiated with respect to x, with y. That's possible, right? So phi is x square. Now using in this result, we are using in equation number 4. X square y plus h of y. H of y. H of y. We should be erasing h of y. It is calculated. H square y plus c. Okay. Okay, and let's go ahead. This is phi. Now, as per the rule, theorem, what they want to use in the problem, theorem, the problem after finding phi, the question says that use theorem 9.9.1. 9.9.1 suggests that integration. So I am writing it in the next page. Theorem 9.9.7 says f dot dr can be written as from a to b as del phi dot dr from a to b, and can be written as phi of b minus phi of a. Okay. Now what is our phi? And for the integration I am repeating here. Integral from 1, 1 to 2, 4. Del of our phi. What is the phi we have found here in this one? X square y plus c. X square y plus c times dr is equal to phi, this one, with upper limit. C remains c, isn't it? So 2 square 4 plus c minus this is in the bracket, this at a lower limit, 1 square 1 plus c, and c positive and negative will be cancelled. Therefore this is 4 into 4, 16, and minus 1, 16, minus 1, the answer is 15. The constant c will be cancelled. This is positive c, this will be negative c. The answer is 15. And use any convenient path between the end points. Question B is use any convenient point between end points. So this is the line. So question B, how to address question B? This is the line, isn't it? The point is A. Point A is 1, 1. Point B is 2, 4. What is the formula to find the straight line joining A and B? Y minus y1 over y1 minus y0, which is equal to x minus x1 over x1 minus x0. Call this one x0, y0. Here, this one is x1 and y1. Substitute this in this equation, you will find this equation. The equation of the straight line joining A and B can be found as y is equal to 3x minus 2. When you substitute here x1 is 2, so y minus y1, y is variable, y1 is 4 minus 4 minus 1, 3, isn't it? So it will be y minus 4 over 3, which is equal to x minus 2 over 1. So 3x minus y minus 4 is equal to 3x minus 6. So minus 4 will be positive 4, you will get this one. We got this equation. Now what we are going to do is, let's substitute this y in the integral. You get the answer. The integration given to us. is 1 comma 1 to 2 comma 4 to xy dx x square dy along the line y is equal to 3x minus 2. Substitute 3. Y, wherever y comes, substitute this one. 2x 3x minus 2 dx plus, therefore what is dy here? Dy is 3 times dx. X square into dy is 3 times dx. Now everything in x, everything is in x. So what is the limit of x? X is first variable, first point, x 1 to 2. So 1 to 2, because here x is lying between 1 to 2 because of the limits. X value should be taken. Now integrate this one, check the answer. Integration has been left to you. This one, this can simplify. 1 to 2, multiply this one, 6x square, this is 2, isn't it, minus 4x plus 3x square dx. Further, if you simplify, 9x square minus 4x dx, you will get 9x cube over 3 minus 4x square over 2 from 1 to 2. This is 3x cube. First time will be 3x cube. X is 2. 3 into 8 minus 2, 4 divided by 2 will be 2, 2x square, 2 into 4, this is for upper limit, minus 9 minus 4. So 18, 24 minus 8 minus, okay, I will solve it differently. Simplify, you have to simplify, that's it. So here it is, it is 3x cube minus 2x square from 1 to 2. When you substitute 2, it will be 2 times 8 minus 2 times 4, 2 times 4 for upper limit, minus lower limit 1. 3 minus 2, 3 minus 2 will be 1. So 3 times 8, 24, minus 8 minus 1 is equal to 15. The same answer what we have got. That's the end of problem number 1. Now we have to solve problem number 10 in the same way. First we have to verify it is conservative or not. So take this is your P and this is Q. Find Py. Differentiate P with respect to y, which is 0 minus u product rule. This will be y, keep y, differentiate sin xy, it will be cosine xy, and when you x minus inside that there will be positive, and keep now sin xy, differentiation of y will be with respect to y, it will be 1 sin xy, close the bracket, minus 5 times y raised to 4. How to differentiate it? 20 y cube. This is your P. Simplify this one, you get minus y cosine minus xy, this x and y together, minus xy cosine xy plus sin xy minus 20y cube. This is just py. And what is qx? Differentiate q with respect to x, minus 20y cube. Isn't it the same term last one? Okay. Next this one needs product rule. Minus inside, this minus inside, keep it here. Keep x and differentiate sin xy, it will be cosine xy times y, plus keep sin xy and differentiate x, it will be 1. It will be 1. So simplify this one. Minus 20y cube minus xy cosine xy plus sin xy. You see the same term, xy is cosine xy is here, sin xy is here, minus 20y. So qx is equal to py. Therefore the f vector is conservative for problem number 10. First part is done, isn't it? Therefore the integral, you can write the integral is independent of the path. That is the first conclusion. Next, find phi potential. See, let's start solving the same problem on the white sheet. Okay, also given what is it? Therefore there is a function, this symbol stands for there exists a function, a scalar function phi such that f vector can be expressed as the gradient of phi, isn't it? Now our aim is to find phi. What is the given integration? One more time, from negative to 0 is 1 comma 0. See, this is the point, both the points on x-axis. See, minus 2 comma 0 is on x-axis negative side, 1 comma 0 is also on x-axis. So this path is on y-axis, I mean x-axis. So the integration I am writing one more time, 2x minus y sin xy minus phi y raised to 4 dx, the first part, minus 20xy cube plus x sin xy dy, isn't it? This term times dx and this term times dy, that's it. And we know f vector is del phi, and there since f vector is equal to del phi. What is del phi? F vector on the left side, which is 2x minus y sin xy minus 5y raised to 4 I vector minus 20xy cube plus x sin xy j vector. This is f, which is equal to phi x I phi y j. This is the meaning of del phi gradient, isn't it? Now we know that phi x is this term, phi y is this term. That's what we are going to write. Phi x is 2x minus y sin xy minus 5y raised to 4. 5y raised to 4. This is pi x. Next pi y minus 20xy cube minus x sin xy, isn't it? xy. Okay, from phi you will find integrate phi with respect to x partially, keeping y as a constant. When you integrate, what do you get? Phi. Integrate this term, it will be 2x square over 2, it will be x square. Integrate this term with respect to x, minus y, sin will be cosine xy, and the coefficient of x is y, so y in the denominator. minus integrate this one with respect to x, 5y raised to 4x. And when you integrate with respect to x, the constant term should be a function of y. We call it g of y, isn't it? So this is equation number 1, this is equation number 2, and this is equation number 3. Simplify 5 one more time. You can write 3 here. 5 is x square minus cosine xy minus 5y raised to 4x plus g of y. If you know what is g of y, you got it. You got 5. Isn't it? So what is 5? Differentiate again with respect to y partially to compare with equation number 2. Differentiate this one with respect to 5 partially. What do you get? This will be 0, this will be cosine, derivation of cosine will be minus sine, so minus and minus will be plus sine xy, and the coefficient of y is x, and the coefficient of y is x, isn't it? So we are differentiating with respect to y, sine xy, so this will be x. Differentiate with respect to y minus 20y cube x, and when you differentiate this one with respect to y, it will be g prime of y. Question number 4. Compare 2 and 4. 2 and 4 will give you 5y here, 5y there, isn't it? This term is here, minus 20y x y cube x. This term sin xy x is available. Missing term is this one. So g prime of y is equal to 0. This gives, and you know, g does not have x, because if it has x, it will not be 0 here, isn't it, when you differentiate? So when it should be function of y alone, and integrate this to, when you differentiate with this y, it can be either a constant or a function of y. So g dash of y equal to 0, derivation is 0, that gives g of y is a constant c. G of y is another constant c. Now equation 3 is rewritten. We will write from equation 3 what is original phi. The original phi is going to be written right now. Therefore equation 3 gives, what is equation 3? This one, x square minus cosine xy, x square minus cosine xy minus 5y raised to minus 5xy raised to 4 plus a constant c. This is our function phi. This is our function phi now, isn't it? And now by the theorem, by theorem 9.1, see, we can ignore this constant, because the while integrating the constant, there will be, see, when you write phi of b minus phi of a, in the previous problem we have seen the constant c, here it will be positive c, here it will be negative c, it will be cancelled, isn't it? So ignore this c, you can ignore this c. Integral from negative 2, 0 to 1, 0 f dot dr can be written as minus 2, 0 to 1, 0 del phi dot dr, which is phi of b minus phi of a. This is theorem, the question says theorem 9.9.1. so phi is given here, phi of b is upper limit, so phi of 1, 0 minus phi of minus 2, 0. What is it? Phi of 1, 0. Ignore the c. In this phi, substitute 1, 0. X is 1 minus cosine 0 is 1. minus phi is 0. This is upper limit minus this is 0, isn't it? Minus lower limit. X is minus 2 gives this term is 4 minus cosine y is 0. Cosine 0 is again 1 minus 0. So what you get? 4 minus 1 is 3. So minus 3 is the answer. This time will be entirely 0. Here 4 minus 1 is 3, minus 3 is the answer. And along any path, there is a third part for this question. Along any path, we know that the lower limit minus 2, 0 and the upper limit 1, 0 are lying on x-axis, because see, y part is 0 both the cases. Therefore, the choice of line is x-axis, which is y is equal to 0. So y equal to 0 gives dy is also 0 in this equation. In the integration, here x is from minus 2 to 1, so integration minus 2 to 1, go back. This is the given integration. Where is it? This is the given integration, right? Here x will be x, we are going to integrate with respect to x. Y will be taken as 0. I will rewrite it. That's good to understand. Here the function is minus 2 comma minus 2 comma 0 to 1 0, isn't it? The function is 2x minus y sin xy minus 5y raised to 4 dx minus 20xy cube plus x sin xy dy, and y equal to 0, dy equal to 0. Second term will be 0 wherever y comes. So substitute x is lower limit is 2, upper limit is 1 for x. 2x, this part y is 0, this part y is 0, everything is 0. So only 2x dx. It will be integration x square 2x square over 2 from minus 2 to 1. You can find the answer is minus 3 very easily. So the two problems have been solved. Now let's go back to the PowerPoint, and now the next problem is determine whether the given vector field is conservative if the potential function, again only two-dimensional case you can try. I would like to go the same type problem, isn't it? Just find phi, that's all. You don't need to integrate it. Verify this is your p, this is your q, isn't it? Whether py is equal to qx, then answer this conservative field, and then find phi. That's all, just like the previous problem method. So I leave this problem again, a repetition, isn't it? So answer is here 21. It's a three-dimensional case. There are three terms. First, we have to show that in the integration is independent of path. It means that we should say that f vector is conservative. That is, we should prove del cross f is 0, because there are three terms. If there are only two terms, very easy. We can check py is equal to qx, isn't it? Okay, we need to prove the determinant is 0. This is p, this is q, this is r for a function f, isn't it? Okay, now verify first for conservative and then evaluate. Evaluation can be done by using phi, upper limit and phi minus lower limit and phi, isn't it? This is upper limit, this is lower limit. Okay, the same concept but for three dimensional functions. Okay, let's go ahead. we have to verify what is del cross f. F vector has been taken from the given integration. This is p. F vector is pi qj and rk. That's given here. PQR in the integration. Now I j k dou by dou x, the components of del, dou by dou y, and dou by dou z. First component is 2x sin y plus e raised to 3z. Second component is x square cosine y. Third component is 3x e power 3z plus 5. Now determinant I times, see, when you take I, the determinant of these 4 terms, this with respect to y, there is no y, so this term is 0. With respect to z, this one, there is no z, so this term is also 0. Minus j, when you take j, these 2 terms with these 2 terms, and dou x with respect to this one, dou x, when you differentiate with respect to x, what do you get? 3 times e power 3z plus 0 minus, when you differentiate this one with respect to z, the first term has no z but the second term has, so 3 times e raised to 3z. Again this part will be 0 plus k vector is equal, because same term, isn't it? K vector, first determinant of these 4 terms, there is x here, so 2x cosine y, this one will give you minus 2x cosine y, so everything is 0, same term. Del cross f is 0, f vector is conservative, therefore independent of path. First question and be answered. Find phi, that's next. Find phi. And to find phi, we know therefore there exists a function, there is a function, this notation stands for there exists a function which is scalar phi such that f vector can be expressed as del phi, and we know f vector is this one, isn't it? F vector, that is 2x sin y I plus e raised to 3z times I x square cosine y j plus 3x e power 3z plus 5k is equal to phi x I, phi y j, phi z k. Clear? So first phi x goes with this one, phi x is this one, phi y is this one. Component wise, when 2 vectors are equal, component wise they are equal, isn't it? Therefore, what is phi x? Phi x is 2x sin y plus e raised to 3z. What is phi y? X square cosine y. What is phi z? 3x 3z plus phi 3x e power 3z plus phi. We got 3. From phi x we continue. We integrate. Therefore, when integrate with respect to x, what you get is x square sin y plus x into e power 3z, another function in h. Since another function in h. Since this derivation gives 0 here, this function can be a function of not x but maybe y and z. So when you differentiate this phi with respect to, you get this one. So this third term has been 0, so it can be a function of y z. So partial derivation with respect to x gives 0 here. So h of y z. Now differentiate this one with respect to y. You get x square cosine y plus second term there is no y, 0. The third term it will be derivation with respect to y, h y. When we are differentiating with respect to y, of y comma z. Now this is actually equation number 1, this is 2, this is 3, and this is 4. Compare 2 and 4. 2 and 4, what do you get? H prime, isn't it? H prime of y is 0. H prime, this time there is no H prime here, so H prime, H derivation with respect to y of y comma z is 0. It means that it should be only a function of z, there is no y. So you can further write, this gives that H prime of y comma z is equal to g of z. This is your equation number 5. H of y, not x. When derivation with respect to y is 0, there is no y. It must be only a function of z. So g of z is g. We have taken notation g of z. So h of y z is in this equation. We can substitute. We can call it a. So substitute this 5 in a. 5 in a. A is here. H of y z will be g of z, a function of this. So I am writing that off. So here 5, as far as now, 5 square sin y plus x into e power 3z plus g of z. This is our equation number 6. Now if you find what is g of z, we are done. Again we have to do some more work, isn't it? G of z. Now take differentiate this one with respect to z. Phi z. First term has no z, 0. Second term has z. So 3x e power 3z. And this will be g dash of z. Call it equation number 7. Now compare 7 and 3. See, 7 is here, 3 is here. This term is available and there is g dash of z is 5. So what do you get? 3 and 7 gives g dash of z is equal to 5. Therefore integrate it. G of z is 5 times z. 5 times z. So we got g of z. This is our equation number 8. Use the 5z in equation number 6. 8 in 6 will get you the final value of pi. Now I am writing the final value of pi, isn't it? Yeah, I am writing this g of z is equal to 5z in equation number 6. So instead of this one, you'll get. So what is finally pi? X square sin y plus x into e raised to 3z plus 5z. That is it. Therefore integration from 1 comma 0 comma 0 to 2 comma pi by 2 comma 1 f dot dr is phi of 2 comma pi by 2 comma 1 minus phi of 1 comma 0 comma 0, phi of a minus phi of b minus phi of a. Substitute in the phi. Equation number will be 9 something. So what is pi of 2? X square is 2, pi by 2 is sin pi by 2 is 1. So x square is 2 4 plus here x is 2 e power 3. There is no y. And 2 into e power 3 plus z is 1 gives plus 5 minus x is 1, y and z are 0. So this will be 0. This will be e power 0 is 1 and last one is 0. Minus only 1. So this 5 plus 4 plus 5, 9 minus 1 is 8. 8 plus 2 into e raised to 3. That's the end of this problem. And to complete this chapter we have one more problem. The answer is given here. What we gotta do is f dot evaluate f dot dr. We have to verify this f vector is conservative. Del cross f is 0 or not. That verification has been left to you. So it's 0. We have verified here. You can see. They have used the shortest. That's not shortest method. They have. You should have an idea about the determinant. Then you can say what are these things. Verify, and then if this is 0, we know that f vector is equal to del pi. Find phi from f by using f common, and this is your e raised to z e2, and this is phi x, this is phi y, this is phi z. Using the same, we are finding phi. Okay, and this there will be phi. The phi has been found here finally. Where is phi? It's just like the previous problem. Go ahead. Now when you find phi, obviously upper limit is 248 in the phi. Substitute upper limit to 248, and again lower limit is -1 to -111. That's it. We don't want this r actually. In this method you can solve. Otherwise, the method that we used the previous chapter, substituting x and y z values from r in this one and converting everything into t and then finding a t value, right? That's also good. The better is this method. Find phi in the similar like the previous problem and then substitute upper limit here and lower limit. The answer is given as this one. Verify yourself, and if you have doubts with this problem, you can discuss with me in the live classes, right? Thank you very much. That will be the end of this chapter. This will be for week 9, will be dealt later on. Thank you.